Hello friends, I welcome you to my YouTube channel. In this video we will continue with our fluid kinematics videos, and in this video we will study about rate of flow or discharge Q, and then continuity equation, and then we will solve a numerical problem which is based on the continuity equation. Okay, so first of all, what is the rate of flow or discharge? Let's remove this question. Let's move it down so that we will solve it later. First of all, let's understand other two things. What is the rate of flow or discharge? So rate of flow is denoted as Q, which is mass flow rate of a fluid per second. Okay, so or it can also be volume per second. Okay, so it can be meter cube per second. And how to calculate it? Then it will be equal to area into velocity. It will be equal to mass volume flow rate. Okay, and if you multiply it by density, then it will become mass flow rate. But what is the continuity equation? Continuity equation is based on the conservation of mass. Okay, it means that continuity equation means that mass entering at cross section will be equal to mass exiting from another section if there is no change in between in the fluid. Okay, so suppose at point 1 density is ρ1, velocity is v1, area is a1, and suppose at section 2 density is ρ2, velocity is v2, and area is a2. Then we can conserve the mass at section 1 and 2, and the equation we will get will be the continuity equation. So rate of flow at section 1 will be flow rate Q at or flow rate at 1 mass flow rate at 1 is equal to ρ1 a1 and v1. Similarly, flow rate at 2 will be ρ2 a2 into v2. So according to the law of conservation of mass, rate of flow at section 1 will be equal to rate of flow at section 2. So ρ1 a1 v1 is equal to ρ2 a2 into v2. So this is called the continuity equation. And if the fluid is incompressible, then density will be constant. So if fluid is incompressible, then a1 v1 is equal to a2 v2. Okay, this is continuity equation for incompressible flow. Okay, now we will solve a numerical problem which is based on the continuity equation. So let's see this problem. The diameter of the pipe at section 1 and 2 are 10 cm and 15 cm respectively. Find the discharge through the pipe if the velocity of water flowing through the pipe at section 1 is 5 meter per second. Okay, determine also the velocity at section 2. So we have d1 and d2. So d1 is equal to 10 centimeter, d2 is 15 centimeter. So we will try to find area, because in continuity equation we need area. So a1 is equal to pi by 4 d1 square, which will be equal to pi by 4 into 0.1 square, which is 0.007854 meter square. Similarly, a2 is pi by 4 into d2 square. Sorry, I have written a small letter, but it's same as capital letter. Okay, so it is equal to pi by 4 0.15 square, which will be equal to 0.01767 meter square. So we have found our areas. So discharge through pipe, discharge will be equal to flow rate. Q is equal to A1 V1 is equal to A2 V2. Okay, so A1 V1 is area at point 1 is 0.070078854 into V1 is 5 meter per second, so it will become 0.03927 meter cube per second. This will be discharge, okay, through pipe. Now we have to find velocity at point 2. So conserving the momentum, conserving the mass, A1 V1 is equal to A2 V2. Okay, we are assuming that is incompressible flow. So A1 V1 is equal to A2 V2. So from here we get V2 is equal to A1 V1 by A2, which will be equal to 0.0078854 into V1 is 5 divided by 0.01767. Okay, so it will be equal to 2.22 meter per second. So this is velocity at section 2. Okay, so I hope you understood what is the continuity equation in basic form. There is another continuity equation, it's a 3-dimensional form in differential equation, but for now we are studying the simple one, and we have also solved a numerical problem which is based on the continuity equation. So if you have any doubt, you can ask in the comment section, and if you like this video, please share and subscribe. Thank you for watching.